homework tonight is just going to be an arc length, but tomorrow is going to be on area of a sector. And your group work today, you're going to need both, but you have today and tomorrow to work on it. First, we're going to draw a circle. Okay. We're going to find the length from our A to C. Now, in the past, you found the angle from A to C. This is the length. This is like if I took a string and drew it. Where an angle is like if I made it with a protractor. Okay? This is theta. I'm finding this length right here. Okay? So I'm going to write find the length of AC, arc AC. Okay? We're going to take, and we did this before, I introduced this before, theta, or the angle, over 360, the degrees of a circle, equals, so it's going to have the same proportion of the length of AC all over 2 pi r, the circumference. Okay? Now we've got sector area. That's like the area of a piece of pie. So if we have A, B, C, where this is theta, I literally want to know the area of just this piece of pie. Okay? So this is find the area of the sector. So that is going to be the angle over 360 equals area of the sector over pi r squared, the area of a circle. Anybody have any questions about that so far? Do you guys remember theta just stands for whatever that angle is? It's just like using x.
This is a lot of drawing.
Yeah, the drawings I think will help you on your test though. If you don't remember what something's called, you can look up the drawing instead. Which is why we're doing it for the circle book. Yes. So I want the area of this piece of pie over the area of the whole circle. It's going to be the same proportion as the angle of the sector over 360, the angle of the whole circle.
So you're going to find that first and then do...
So we're going to do problems where you're missing a piece of this and you cross multiply to find it. But you could miss any of those pieces.
Wait, so which one did you use?
So if you're finding arc length, so it says if they want the distance around a part of a circle, use arc length. If they want area of a part of a circle, you use area of a sector. All right. Any other questions? Those were really good ones. Okay, let's look first at your homework. Okay, I'm going to skip the top part because I think you guys can do circumference by now, okay? We're going to do one of these at the bottom. We're going to do number 9. Okay, so I know the formula. I'm going to put the formula right on top so I remember what it is. It's going to be, all of these are for arc length. So I'm going to use the angle over 360 equals the length of the arc over 2 pi r. Okay? So I'm going to say 90 degrees, because that's my angle, over 360. Whoever music is playing, can we turn it off? Not only is it not according to our norms, but it also, in recording this right now, you should not have your headphones on at all, and you should not be on your phones at all. You should be paying attention, following along. Okay. 90 over 360 equals the arc, the length of the arc, which I don't know. Okay, I'm going to state this one more time, and then I'm just going to walk around and take phones that I see out or headphones. You may not have your music playing right now at all, and I definitely shouldn't hear it. Okay, so it's x over 2 pi times 8. 8 is the radius. Okay, so now I'm just going to cross multiply to figure these out. I'm just going to do this all together. In my calculator, I'm going to put 90 times 2 times pi times 8. And I'm going to get 4,523.9 equals 360x. Did you do 90 times 2 times pi times 8? Okay. Now I'm going to divide by 360. And I'm just going to get x equals, it says round to the nearest tenth, so I should just have one place after my decimal. X is approximately 12.6. Okay. Any questions about that? Yes. Where did I get what? I divided by 360. The back is exactly the same. These want the exact length of the arc. So when they say exact length, they mean they want you to stay with pi. Okay, I'm going to do an example for number 15, yes.
How do you do pi?
You push the pi button.
Oh, I see it now.
Okay. So number 15, I'm going to go 90 over 360 equals x over 2 pi 8. Okay, I want to keep the pi. So when I multiply this, I'm going to go 90 times 2 times 8 gives me 1,440 equals 360x. And that's 1,440 pi. Okay? I'm going to take 1,440 and divide 360 by it. Dividing 360. I'm not timesing it by pi. Because it says I want it the exact length. Okay? So I get 4 pi equals x. That's it. That's my exact length. And that's kilometers. The only thing you do is you don't times by pi. You just bring it with you. So you go 90 times 2 times 8 is 1,440. And I put the pi at the end. I divide by 360, and I just bring the pi down, and I get 4 pi. Does that make sense? Okay, so whenever it says exact length, don't times it by pi. Kilometers. Okay. Today's assignment. Let's go through this together. Okay. Skateboarding has become a popular sport. The Parks Department is thinking of constructing ramps in some of the local playgrounds. A half-pipe ramp is formed by 2 quarter circles. How much is a quarter of a circle? Instead of half a circle, it's a fourth of a circle, right? Okay. Each of which is 10 feet high, plus a flat space of 20 feet long between the centers. Okay? So, find the distance a skater travels from the top of the ramp to the top of the other. from the top of one ramp to the top of the other. Another launch ramp is formed by two arcs, each with a central angle of 60 and a radius of 10. Find the length from the top of one ramp to the top of the other. What fractional part of the circle is each arc? So you know you have two different questions here. One uses the picture exactly, okay, for number one. Number two, we changed it. Instead, we don't have 1/4 of a circle. We're using 60 degrees, and we have to figure out, okay, what fraction of that circle is in order to find the length from one top of one ramp to one field. Okay? Number three, a third ramp has two straight ramps, each of which is 4 feet high and 10 feet long, with a flat space of 20 feet in between. Find the distance a skater travels from the top of one ramp to the top of the other, from point P to point R. And you're just going to use Pythagorean theorem to find what x is, and then it should be pretty straightforward. Okay? Please turn it over. Okay. Now, this is the first part on the front is all about arc length. The back is all about area. Okay? You have a cake that is 10 inches in diameter. You expect 12 people to share it. So you cut it into 12 equal slices. Okay? And find the area of each slice of cake. Okay? So if you look at figure A, if a cake with a 10-inch diameter is cut into 12 pieces, how big of an area is each piece? Before you get a chance to serve that cake, so you have to figure out number one first. Before you get a chance to serve that cake, 12 more people arrive. So instead, you just decide to cut a circle right in the middle, like figure B. And so you decide to cut a circle in it, so you have 24 people. How far from the center of the cake should the circle be cut so that all 24 people get the same amount of cake? Oh, there's only 3 questions on the back as well as on the front. There's just a number 2 next to directions. That's nice. Okay? Number 4, what is the area of each segment of cake? How much cake will each person receive? That's for 24 people. So my suggestion again is if you have 4 people at your table, for 2 of you to try the first 3 together, and the other 2 to try the second 3 together, it'll mean you can actually do this. So you have the rest of the hour to work on this, and we're going to have some time at the beginning of class on tomorrow, on Thursday. But then we are going to share out our answers. Okay? So, you need to do that. You need to figure out what part you're doing and participate with this. Remember, your classmates are going to grade you. All right, guys, go ahead, get started.